Good morning everyone. So we are back again. Students, in the last class we completed few question and answers of the first chapter, that is matter in our surrounding. Yes. So today we will continue from question number 9. Okay. The last question was liquids generally have lower density as compared to solids. But you must have observed that ice float on water. Find out why. This was your last question. So today we will continue with the next question, that is question number 9. Okay. So let's move towards the question and answers. So students, our next question, that is question number 9, is convert the following temperature to Celsius scale. Okay, you have to convert the following temperature that is given into Celsius scale. Okay, the temperature that is given, number A, that is 300 K. 300 K means 300 Kelvin. Okay, and B is 573 Kelvin. Okay, so these are the two temperatures that is given. You have to convert this Kelvin, this temperature that is given in Kelvin unit, you have to convert that into Celsius. Okay, so students, as you know, 0 degrees Celsius is equal to 273 Kelvin. Okay, 0 degrees Celsius is equal to 273 Kelvin. Understood? So, to convert Kelvin into Celsius, what you have to do? You have to subtract the given temperature by the value of the given degree. Okay, that is 0 degree is equal to 273 Kelvin. You have to subtract it. Understood? 0 degree is always equal to 273 Kelvin, and here it is asked that you have to convert this Kelvin into Celsius. So for that, what you have to do? You have to subtract the given temperature with the value of 0 degree Celsius, that is 273 Kelvin. Okay, so what is the formula for it? You have to, temperature given in Celsius is equal to temperature given in Kelvin subtracted by 273. What is the formula? Temperature given in Celsius is equal to temperature given in Kelvin subtracted by 273. Okay, so the first temperature that is given, how much it is? 300 Kelvin. Yes or no? Number A, 9A. What is the temperature given? It is 300 Kelvin. So how will you convert it to Celsius scale? By applying this formula. Okay, temperature in Celsius is equal to temperature in Kelvin subtracted by 273. That will be 300 minus 273. Okay, and the answer is 27 degree Celsius. If you subtract 273 by 300, okay, the answer will be 27 degree Celsius. Understood? Now again, number B, the temperature given is 573 Kelvin. Okay, so this one also you have to subtract with 273. Okay, so the solution will be temperature in Celsius is equal to temperature in Kelvin subtracted by 273. Okay, so it is equal to 573 minus 273 Celsius, that is 300 degree Celsius. The answer will be 300 degree Celsius. I will repeat once again. As we know, 0 degree is equal to 273 Kelvin. Okay, here you have to convert this Kelvin temperature into Celsius scale. Okay, so the first one is given 300 Kelvin. You have to convert this 300 Kelvin into Celsius scale. So it will be temperature in Celsius is equal to temperature in Kelvin minus 273. That is 300 minus 273. The answer is 27 degree Celsius. Okay. The number B. The temperature is given 573 Kelvin. Okay. And the solution will be temperature in Celsius is equal to temperature in Kelvin minus 273. Okay. So 573 minus 273 is equal to 300 degree Celsius. Okay. So students, now next question, that is question number 10. What is the physical state of water at 250 degrees Celsius, B 100 degree Celsius? What is the physical state of water, it is asked. Okay, at 250 degrees Celsius and 100 degrees Celsius. Physical state means in what state the water is, in 250 degrees Celsius and 100 degrees Celsius. As we all know, the normal temperature, that is room temperature, is 25 degrees Celsius. In 25 degrees Celsius it is water in nature, liquid in nature. Below 25 degree, that is 0 degree, it is ice state. The state of the water below 0 degree or in 0 degree, it is in ice state. Okay, the normal temperature is 25 degree. Okay, and more than 25 degree if it increase, then if it extend to 100 degrees Celsius, then the liquid changes its state to gaseous state, because when we increase the temperature of a liquid, it evaporates. Yes or no? When we increase the temperature of a liquid, the liquid starts to evaporate, and when it gets evaporated, it turns into the gaseous state. And when we cool down, that means when we decrease the temperature of the water, it condenses. Yes or no? When we decrease, it condenses. So in 0 degree, it turns its state into ice, and the normal temperature is 25 degree. Okay, the room temperature, that is 25 degrees Celsius. Understood? So what is the physical state of water at 250 degrees Celsius? That is more than 100 degree. Yes or no? So in which state it will be? It will be in gaseous state. So the answer is water at 250 degrees Celsius exists in gaseous state because it is more than 100 degree. Okay. Then number B. What is the physical state of water at 100 degrees Celsius? That means at 100 degrees Celsius, water can exist in both liquid and in gaseous state. If you apply heat, it will turn into gaseous state, or it may also remain into liquid state. Okay, so at 100 degrees Celsius, water can exist in both liquid and gaseous form. Full stop. At this temperature, after getting the heat equal to the latent heat of vaporization, water starts changing from liquid state to gaseous state. As I already As I already told you, if you apply heat, if you increase the temperature of a liquid, it gets evaporated, that is vaporization. Okay, vaporization means changing into vapor. So, it will turn into the gaseous state. In 250 degrees Celsius, it is in gaseous state because the temperature is more than 100 degrees Celsius. Okay, and in 250 degrees Celsius, it is in gaseous state, and in 100 degrees Celsius, it may be in liquid state or it can be also in gaseous state because there is increase of the temperature. Understood? So students, now question number 11. For any substance, why does the temperature remain constant during the change of state? I repeat the question. For any substance means for any matter, whether it is solid, liquid or gas. Okay? For any substance, any matter. Why does the temperature remain constant during the change of state? That means when a matter is changing its state, the temperature remains constant. Whether the temperature is increasing or decreasing, it always remains constant. That means it is unchanged. The temperature does not change. Why is it so? The answer is, I will read out. During a change of state, the temperature remains constant. Full stop. This is because all the heat supplied to increase the temperature is utilized in changing the state by overcoming the forces of attraction between the particles. Full stop. Therefore, this heat does not contribute in increasing the temperature of the substance. Okay? During a change in state, when a matter is changing in state, heat is supplied. Okay? When a matter changes its state, heat is supplied for increasing the temperature. When you want to increase the temperature, to change the state of a matter, then heat is applied. Yes or no? To increase the temperature, you apply heat. And to decrease the temperature, you decrease the heat. You do not apply heat to that. You cool it down. Yes or no? So, this temperature is utilized. The temperature that you provide in increasing or decreasing, it is utilized in changing the temperature. Okay? By overcoming the force of attraction between the particles. You know that there is some force of attraction between the particles of the matter. They attract each other. Okay? Hence, this heat does not change. Therefore, this heat does not change. It remains constant. Because if the heat will change, the state of the matter will not change. Okay? That is why the heat remains constant during the change of a state of any substance. Understood? So students, now question number 12. Suggest a method to liquefy atmospheric gases. Suggest a method to liquefy atmospheric gases. Liquefy means to change it into liquid, the atmospheric gas. How will you change it? The answer is by applying pressure and reducing the temperature, atmospheric gases can be liquefied. When you apply some pressure and when you decrease the temperature, okay, when you decrease the temperature of the gas, that means when you condense, okay, when you condense by applying some pressure, the atmospheric gas can be liquefied. That means the atmospheric gas can be turned into liquid form, can be turned into liquid state. Understood? I will repeat the question and answer once again. Question number 12. Suggest a method to liquefy atmospheric gases. The answer is by applying pressure and reducing the temperature, atmospheric gases can be liquefied. Okay. Question number 13. Why does a desert cooler cool better on a hot, dry day? I repeat, why does a desert cooler cool better on a hot, dry day? What is the reason behind a cooler? That it gives you cool air. You use cooler at home, everyone, right? What is the reason behind it that you get cool air from the cooler? What is the reason? The reason is that when a liquid evaporates, the particles of the liquid absorb energy from the surrounding to compensate the loss of energy during evaporation. This makes the surrounding cool. Okay. When a liquid evaporates, that means what? When the temperature is increased, when the temperature of a liquid is increased, it evaporates. Yes or no? Then the particles of the liquid absorb energy from the surrounding. And the particles that the liquid contains, when it gets evaporated, it absorbs the energy from the surrounding. Okay. To compensate the loss of energy during evaporation. When they are evaporating, they are losing their energy. So that is why they try to absorb the energy from the surrounding. Okay. That is why this makes the surrounding cool. When they absorb the energy from the surrounding to compensate the loss of the energy while evaporation. They absorb the energy from the surrounding, which makes the surrounding cool. Okay. In a desert cooler, the water inside is made to evaporate. Full stop. This leads to absorption of energy from the surrounding, thereby cooling the surrounding. Full stop. Again, we know that evaporation depends on humidity. If the amount of water vapor present in air is less, then evaporation is more. On a hot, dry day, the amount of water vapor present in air is less. Full stop. Thus, water present inside the desert cooler evaporates more, thereby cooling the surrounding more. That is why a desert cooler cools better on a hot, dry day. Why does a desert cooler cools more in a hot, dry day? Because when a liquid evaporates, it absorbs the energy from the surrounding. And while absorbing the energy, why does it absorb the energy from the surrounding? Because while evaporation, the liquid lost its energy. Because the temperature is increased. Okay. And we know that evaporation depends on humidity. You know what is humidity? Humidity is the amount of water vapor that is present in the atmosphere. That means in the air around us. Amount of water vapor that is present in the air around us is called as humidity. And evaporation depends on humidity. How much water vapor is present in the air? According to that, the evaporation process takes place. Okay. If the amount of water vapor present in air is less, evaporation is more. If the humidity is less in the atmosphere, then the evaporation is more. Okay. So, on a hot, dry day, the amount of water vapor present in the atmosphere is less. That means the water vapor present in the air is less. That is why the water present inside the cooler evaporates more. Okay, it evaporates more and it absorbs energy from the surrounding, making the surrounding cool. That is why a desert cooler cools better on a hot, dry day. Understood? So now students comes question number 14. How does the water kept in an earthen pot, that is matka, become cool during summer? I repeat, how does the water kept in earthen pot, that is matka, become cool during summer? The water that you keep in matka, the earthen pot, the pot that is made of mud, the water if you keep there, why does it cools down in a summer day? The reason is, answer, there are some pores in an earthen pot. There are some tiny pores into the earthen pot through which the liquid inside the pot evaporates. Yes or no? When a liquid evaporates, it makes the surrounding cool. This evaporation makes the water inside the pot cool. In this way, water kept in an earthen pot becomes cool during summer. So what is the reason behind it? The earthen pot contains some tiny pores in it, which helps in evaporation. And when evaporation takes place, it absorbs the heat from the surrounding. Yes or no? Making the surrounding cool. That is why the water kept in the matka becomes cool during summers. Okay? So students, now question number 15. Why does our palm feel cold when we put some acetone or petrol or perfume on it? I repeat, why does our palm feel cold when we put some acetone or petrol or perfume on it? What is acetone? The nail remover or the spirit that is used in the hospitals while injecting you. Yes or no? And the nail remover used to remove the nail polish. That is acetone. Okay. And petrol, you know what is petrol, is a fuel. And perfume. When you put it on your palm or your hand, on your skin, why do you feel cold? What is the reason behind it? The answer is, when we put some acetone or petrol or perfume on our palm, it evaporates. Full stop. During evaporation, particles of the liquid absorb energy from the surrounding or the surface of the palm to compensate for the loss of energy, making the surroundings cool. Full stop. Hence, our palm feels cold when we put some acetone or petrol or perfume on it. As I already told you, when acetone or petrol or perfume is put on your palm, it gets evaporated. Why? Because it gets evaporated due to the temperature of our body. Okay. Due to the temperature of our body, the acetone or petrol or perfume, it gets evaporated. And these three substances are in which form? They are in liquid form. Yes or no? So they get evaporated due to the temperature of our body. And when they get evaporated, when the liquid gets evaporated, it absorbs the energy from the surrounding. Yes or no? It absorbs the energy from the surrounding to compensate the loss of energy. And when a liquid is evaporated, it lost its energy. That is why it absorbed the energy from the surrounding. That means it absorbed the energy from the surrounding of our skin. So that is why when there is a process of evaporation, it makes the surrounding cool. So this is the reason why we feel cool when acetone or petrol or perfume is put in our palm or on the skin. Understood? So students, now question number 16. Why are we able to sip hot tea or milk faster from a saucer than a cup? I repeat, why are we able to sip hot tea or milk faster from a saucer rather than a cup? Okay. The answer is a liquid has a large surface area in the saucer than in a cup. A liquid has larger surface area in a saucer than in a cup. Full stop. Thus, it evaporates faster and cools faster in a saucer than in a cup. Full stop. For this reason, we are able to sip hot tea or milk faster from a saucer than a cup. Okay. So, saucer means the plate. Okay, the cup and plate. When you pour tea into that plate and when you drink, it gets cool faster. Yes or no? It cools down faster. Why? Because the surface area is larger of the plate than that of the cup. And when the surface area is larger, the evaporation is more. And when the evaporation is more, the surrounding gets cooled down. Yes or no? When a liquid evaporates, it cools down. Yes or no? So, that is why hot tea or milk cools faster in a saucer than in a cup. Understood? Students, you also mind this thing. If evaporation is more, humidity is less. Okay. If the evaporation is more, the humidity is less. That means the water vapor in the atmosphere is less. But if the evaporation is less, the humidity in the atmosphere is more. That means the water vapor in the atmosphere is more. Understood? Liquid evaporated means the water vapor. The water change into vapor. Understood? When a liquid evaporates, that means when you increase heat into the liquid, it evaporates. That means when a liquid evaporates, it changes into vapor. That means into the gaseous state. And this is the reason why it gets cool very faster. Okay. So students, now question number 17. What type of clothes should we wear in summer? What type of clothes should we wear in summer? The answer is, we should wear cotton clothes in summer. Full stop. During summer, we sweat more. Full stop. On the other hand, cotton is a good absorber of water. Thus, it absorbs sweat from our body and exposes the liquid to the atmosphere, making evaporation faster. During this evaporation, particles on the surface of the liquid gain energy from our body surface, making the body cool. I repeat the answer again. We should wear cotton clothes in summer. During summer, we sweat more. On the other hand, cotton is good absorber of water. Thus, it absorbs sweat from our body and exposes the liquid to the atmosphere, making evaporation faster. During this evaporation, particles on the surface of the liquid gain energy from our body surface, making the body cool. Now, why should you wear some cotton clothes in summer? In summer, we sweat a lot. Yes or no? We sweat a lot during summer days. And cotton is a good absorbent of heat. Okay. Cotton is a good absorber of water. The sweat that comes out, if you wear cotton clothes, it absorbs the heat. When it absorbs the heat, it makes it to evaporate faster. And when evaporation is done, it loses its energy. Yes or no? The liquid loses its energy and it absorbs the energy from the surrounding. Yes, it's absorbed the energy from the surrounding, which makes our body feel cool. That is why we should wear cotton clothes in summer. Okay? So students, now question number 18. Convert the following temperature to the Celsius scale. As you did the earlier question? You converted the temperature into Kelvin into Celsius, yes or no? 0 degree is equal to 273 degree Celsius, 273 Kelvin, yes or no? So you have to convert the following temperature to the Celsius scale. That is, number A is 293 Kelvin, number B is 470 Kelvin. You have to change this Kelvin into Celsius. So 0 degree is equal to 273 Kelvin. Now you have to change into Celsius, that means you have to subtract. So number A, 293 Kelvin is equal to 293 minus 273. Okay, the answer will be 20 degree Celsius. Yes or no? To change the temperature from Kelvin to Celsius, you have to subtract. But if you need to change the temperature from Celsius to Kelvin, you have to add. Because the temperature in Kelvin is always high and the temperature in Celsius is always less. Okay? So 293 Kelvin is equal to 293 subtracted by 273 degrees Celsius, that is equal to 20 degree Celsius. Okay? And number B, 470 degree Kelvin. 470 Kelvin. Okay, you have to change this 470 Kelvin into Celsius. So the answer will be 0 degree Celsius is equal to 273 Kelvin. Okay, so 470 Kelvin is equal to 470 subtracted by 273 degrees Celsius. That is, the answer is 197 degree Celsius. When you subtract this 470 to 273 degrees Celsius, the answer will be 197 degree Celsius. Okay. So now again question number 19. Convert the following temperature to the Kelvin scale. I already told you, if you are changing to Celsius, you have to subtract. But now you have to change to Kelvin scale. So now you have to add the temperature. Okay. Kelvin is the SI unit of temperature. Okay. Where 0 degree Celsius is equal to 273 Kelvin. Okay, Kelvin is the SI unit of temperature, where 0 degree Celsius is equal to 273 Kelvin. Okay. Number A, you have to change 25 degrees Celsius to Kelvin. You have to change 25 degrees Celsius to Kelvin scale. So what you have to do? 25 plus 273 Kelvin. 25 plus 273 Kelvin is equal to 298 Kelvin. Temperature is always more in Kelvin scale and in Celsius scale it is always less. Okay. And number B, 373 degrees Celsius is equal to 373 plus 273 Kelvin. Okay, this 373 degrees Celsius you have to change into Kelvin, so it will be 373 plus 273 Kelvin, which is equal to 646 Kelvin. Okay. Now question number 19. Give reason for the following observations. You have to give reason for the following observation. Question number 19A. Naphthalene balls disappear with time without leaving any solid. You know what is naphthalene balls that you keep in your clothes to keep the insects away? That is naphthalene ball. Okay. Naphthalene balls disappear with time without leaving any solid. Number B. We can get the smell of perfume sitting several meters away. Why do we get the smell of perfume sitting several meters away? What is the reason behind it? Okay, so what is the answer? Let us see. Answer to question number 19A. Why does the naphthalene ball disappears? Naphthalene ball disappears with time without leaving any solid as it undergoes sublimation. The change of state of naphthalene from solid to gas takes place easily. These naphthalene balls are in solid form. Okay. And why does it disappear? Because this naphthalene ball goes under the process of sublimation. Sublimation is a process in which the solid is directly changed into the gaseous state. Okay. And these naphthalene balls goes sublimation easily. That is why this naphthalene ball disappears without leaving any solid. That means it changes into the gaseous state. That is why naphthalene balls disappear with time without leaving any solid. Okay. Answer number 19B. Why does we get the fragrance of the perfume far away also? Gaseous particles possess high speed and large space between them. As I told you, the particles of this gaseous always keeps on moving as the molecules are less bounded. Yes or no? So they can travel anywhere with a high speed. Particles of perfume diffuse into gaseous particles at very fast rate and reach our nostril. Yes or no? The gas keeps on moving very fast. So it diffuses in these gaseous particles and it reaches very fast to our nostrils. This enables us to smell the perfume from a distance. Okay, this perfume change into the gaseous state, and we already know that the molecules of the gases are less bounded and it can move very freely. So that is why we can get the smell of the perfume even if we are sitting far. Okay. Students, our next question is, arrange the following substances in increasing order of force of attraction between the particles. That is water, sugar and oxygen. You have to arrange these particles according to their increasing order of force of attraction. That means whose force of attraction is more in the increasing order between the particles water, sugar, oxygen. Okay. So what is the answer? Sugar is a solid. The force of attraction between the particles of sugar are strong. Yes or no? The attraction of the molecules of solid are strong. Water is a liquid. The force of attraction here are weaker than sugar. And the force of attraction in liquid is less than that of solid. Yes? And oxygen is a gas. The force of attraction are weakest. Yes or no? The gaseous have less force of attraction between the molecules. Thus, the increasing order of force of attraction between the particles of water, sugar and oxygen is, that is, oxygen has less force of attraction than water than that of sugar. So, this is the increasing order. First oxygen, then water, then sugar, because sugar is solid, so it has more force of attraction because the molecules are bounded and packed very closely. Then water is a liquid, the molecules are less bounded, and oxygen is air, the molecules are not that much, the molecules are very least bounded, that means very least packed. Okay, so this is the increasing order: oxygen, water, sugar. Okay. So students, our next question is, what is the physical state of water at 25 degrees Celsius? Number B 0 degrees Celsius and number C 100 degrees Celsius. That means you have to say the physical state of water, in which state it is. Okay. Answer is, water at 25 degrees Celsius is present in liquid state. I already told you 25 degrees Celsius is the room temperature, and in room temperature the liquid is always in water state. Yes or no? The water is in liquid state. Sorry, the water is always in liquid state. Okay, that means that is the room temperature. 25 degrees Celsius you will find water in the liquid state. Number B, at 0 degrees Celsius water can exist both solid and liquid. At this temperature, after getting the heat equal to the latent heat of fusion, the solid form of water, that is ice, start changing into its liquid form, that is water. Okay. Now students, what do you mean by latent heat of fusion? Latent heat of fusion means heat absorbed to convert liquid into vapor state. Okay. Heat absorbed to convert liquid into vapor state, that is latent heat of fusion. Okay. So in 0 degrees Celsius water can be both in solid and liquid state. Solid state means it can be in ice state also and it can be in liquid state also. Okay. The solid form of water is ice. Okay. And the liquid form of water is, it is water only, and the liquid form is water. Yes or no? So in 0 degrees Celsius you will find water in both states, solid and liquid state, that means ice and water. Okay. And at 100 degrees Celsius water can exist both liquid and gas. At this temperature, after getting the heat equal to the latent heat of vaporization, water starts changing from its liquid state to its gaseous state, that is water vapor. And in 100 degrees Celsius, that means when you increase the temperature of the liquid, you will find it in both liquid or in gaseous state. Okay, in 100 degree you may find the water in liquid state also and in gaseous state also. Understood? So students, question number 22. Give two reasons to justify. Number A, water at room temperature is liquid. B, an iron almirah is a solid at room temperature. Why water at room temperature is liquid and an iron almirah is solid at room temperature? Okay, the answer of question number 22A is, at room temperature, that is 25 degrees Celsius, water is liquid because it has the following characteristic. Why water at room temperature is liquid? Why? Because number 1, at room temperature water has no shape but has a fixed volume, that is it occupies the shape of the container in which it is kept. Okay, at room temperature water has no shape. It attains, that means it attains the fixed volume. It occupies the space of the container in which it is kept. Okay. And at room temperature water flows. That means it is in liquid form and liquid always flows. Okay. Answer number 22B. It is, an iron almirah is a solid at room temperature because number 1, it has definite shape and volume like a solid at room temperature. Yes or no? The almirah in which you keep your clothes, it is a solid because it has a fixed volume and fixed shape. Yes or no? That is why it is solid in room temperature. It is rigid and as solid at room temperature, and it is also rigid. It cannot be compressed at room temperature. Okay, so that is why it is solid. Now question number 23. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Now 0 degree is equal to 273 Kelvin, that means 273 Kelvin is equal to 0 degree, and in 0 degree water always, not always, it can be in ice form or it can be in water form. Yes or no? So when in 0 degree it is in ice form, it will cool down easily only. Yes or no? So ice at 273 Kelvin has less energy than water because it is in ice form. Okay. Although both are at the same temperature, water possesses the additional latent heat of fusion. Hence, at 27 degree Kelvin, ice is more effective in cooling than water. Understood? Because ice has got more particles. That is why it can absorb the energy from the surrounding, and so it is more cooling, more effective in cooling than water. Okay? So students, now question number 24. What produces more severe burns, boiling water or steam? What produces more severe burn, boiling water or steam? Steam is the water vapor. Okay. What produces more burn? The answer is steam has more energy than boiling water. The water vapor that comes out when the water boils, it has more energy because it evaporates, and when something evaporates, it loses its energy and it absorbs the energy from the surrounding. That is why it has got more energy. Okay. It possesses the additional latent heat of vaporization. I already told you, it absorbs the energy from the surrounding, the vapors from the surrounding. Therefore, burns produced by steam are more severe than those produced by boiling water. Okay? Students, question number 25. This is our last question. That is, name A, B, C, D, E and F in the following diagram showing change in its state. There are different states A, B, C, D, E and F. You have to name the different state. You have to name the change of the state. Okay. Solid, number A, C. Solid, it is changing to liquid. And again, number B, liquid is changing to gas. Again, gas is changing to liquid, and again, liquid is changing into solid. Okay. And then, solid is directly changing to gas. E, can you see the arrow? Solid is directly changing to gas. And again, number F, gas is directly changing to solid. Okay, here what is happening? When solid is directly changing to gas, there is increase in heat and decrease in pressure. Okay, when solid is directly changing to gas, the heat is increased and the pressure is decreased. And when gas is changing to solid state, the heat is decreased and the pressure is increased. So what are the following state? What are the changes in state? Okay, the answer is when solid is changing to liquid, the process is fusion. Okay, it is going through the process of fusion. And when liquid is changing to gas, it is going under the process vaporization. That means evaporation, because there is increase in heat and decrease in pressure. Okay, and when again gas is changing to liquid, it is condensation. And when liquid is changing to solid, it is solidification. That means gas, when cools down, it changes into liquid, and when liquid cools down, it changes into solid. That is solidification, ice form. Okay, and again increase in pressure from solid to gas. The process is sublimation. And again from gas to solid, when there is decrease in heat and increase in pressure, that is also sublimation. Understood? So this is the answer of question number 25. So in the next class, I will give you the question answers of the next chapter. Okay, till then, take care of yourself and study well at home.